Hi everyone, and welcome to another session of Test Automation Engineer Certification. So far we have covered the first two modules, and today we will continue the third one. In the third module we have three sections. 3.1, which we have already covered. 3.2 TAA Design is what we will begin today. So first of all, let's go through the overview of TAA Design. So design plays an integral part in the test automation architecture. If the design is poor, then no matter whatever test automation framework you will use, it's bound to fail. So it's essential that proper attention is given to the design phase of the TAA. Now, for designing a TAA, there are a number of required activities, and this is what we will discuss in this section. So these activities, they might vary depending on your test automation project or even the organization as well. Also, we have to note that each test automation architecture has different complexities. So depending on the complexity of the TAA, either we will be using fewer or more of these activities. So it's not necessary that we have to use all of these. These are more for guidance purpose. So let's just go through them. First one, capture requirements needed to define an appropriate TAA. Compare and contrast different design or architecture approaches. Identify areas where abstraction can deliver benefits. Understand SUT technologies and how these interconnect with the TAS. Understand the SUT environment. Time and complexity for a given testware architecture implementation. And the last one, ease of use for a given testware architecture implementation. So now let's just go through these in further detail. So in today's session, we will be covering the first two, and then in the next session, we will continue with the rest of the activities. Okay, so the first one is capture requirements needed to define an appropriate TAA. Okay, so when we are working on a test automation project, it should be dealt in the same manner as we are dealing any other project, because test automation is just like we are developing any other project. So just like in any other project, before we start development, we just don't start development directly on any project. There is a lot of time which is spent on gathering the requirements, and which is very important. So that's the same thing which is required for any test automation project as well. So questions need to be asked, because unless questions are not asked, like the right questions are not asked to the right people, it's very unclear that what's the goal of the projects. So it's essential that to know that what we need from test automation and what we are trying to achieve, we gather the requirements. And some of these questions, they are mentioned in this section. So first of all, which activity or phase of the test process should be automated? For example, test management, test design, test generation, test execution. So these are like few of the activities or phases which are given over here. So I know that most of all, when we think of automation, we think of test execution, and to be honest, this is mostly what I have also worked on. But nowadays there are so many other tools as well that that makes possible the other activities and phases to be automated as well. So automation in a nutshell can be conducted in other phases as well of the software testing process. So there are now like many AI tools which makes test automation possible for these phases. They can be a machine learning tool which makes it possible to understand the behavior of the application and then design the test cases accordingly, and many tools which are capable of generating test data as well, and then of course eventually also test scripts from it. So there is also a note that test automation refines the fundamental test process by inserting test generation between test design and test implementation. Okay, so now let's first think about the fundamental test process. So this is something which we have already covered in the foundation certification course. So when we talk about fundamental test process, so there are different phases in it, like planning and monitoring and control, analysis and design, implementation and execution, and then in the last we have test completion. Okay, so now over here they are saying that automation refines the fundamental test process. So the fundamental test process which we are usually use for the manual testing automation is basically refining it. And how it's refining it? By inserting the test generation. So we spoke about test generation layer earlier in 3.1. So test generation layer between test design and test implementation. Okay, so just a recap that, okay, in test design what we do that it's an activity which is which specifies the test cases from the test conditions. And when we talk about test implementation, this is the activity that prepares the testware needed for test execution, which is based on the test analysis and design. So now we are inserting test generation in the middle of that, which basically supports the design of test cases. So I hope that this is clear. Okay, let's move on to the next slide. Then the next one is which test level should be supported. For example, component level, integration level, system level. Okay, so these levels we have already covered in the foundation course as well. So I'm sure that you all are familiar with the with all these levels. So we don't need to go into detail. Then the next one is which type of test should be supported. Okay, so it can be functional testing, conformance testing, and interoperability testing as well. Okay, so by the way, these are just few examples. It doesn't mean that only these are the type of testing and only these are the test levels, etc. as well. So this is only like for the purpose of like giving examples. Okay, functional testing we are already aware of that, which basically covers the testing of the functionality of the application. Now the next one is they have given example of conformance testing. So conformance testing is basically which is used to verify the software, that whether the software complies with any standards, industry standards and regulations. For example, let's say that if there is a company which claims that it produces organic food, so then it's tested to confirm that the production of food is free of any synthetic chemical ingredients. Then next one is interoperability testing. Okay, so that one, this testing is to verify software's interaction with any of its components or any other software. So for example, you can take an example of your smartwatch. So you have a smartwatch and then there is an app as well on the phone via Bluetooth. So this will cover this. Right, the next one is which test role should be supported. So it can be test executor, test analyst, test architect, test manager. So we said that there are different activities, different phases which can be automated. So based on that, what kind of project you are working on, the test automation project, these are the considerations to make that when you're working on the TAA design, which role should be supported? Mostly, yes, it's test executor, but it all depends on the type of application you're working on, who will be using it. It will be like test executor, test analyst, it can be test architect, or it can be test manager as well. So it all depends on that. So this is one of a very important consideration to be made during the TAA design. Okay, next one, which software product line, software product family should be supported. For example, to define the span and lifetime of the implemented test automation solution. Okay, so when we are automating a product, let's say, so it's important that, are we automating like one product? Is it like set of products, like product line, or it's like an entire product family? It also depends on like what's the scope of the automation. So let's say that they are already different products, and then you are starting with one, and later on you have to automate the other products as well. Or let's say that there is a new company and they just start with one product and you're automating that, but in your test automation solution you need to make sure that in future, when the company expands, maybe they are introducing another product in future, then your test automation solution should be extendable and maintainable. That's why it said that to define the span and lifetime of the implemented test automation solution. Because if you don't consider it during the design phase of the TAA, then it might be possible that yes, everything is working fine for your current product, but as soon as you introduce any other product, then maybe it will just go obsolete, it will fail, and then maybe you have to start from scratch. So these are very, very good considerations to be made earlier in the automation project. Next one is, which SUT technologies should be supported? For example, to define the test automation solution in view of compatibility to the system under test technologies. So this one is also important as well, because different system under test architecture may require different test automation solutions. So that's like an important consideration as well. Okay, so now let's move on to the next point. So the next point is compare and contrast different design architecture approaches. The TAE, test automation engineer, needs to analyze the pros and cons of different approaches when designing selected layers of the TAA. These include but are not limited to. Okay, so this is a very important role of TAE, that there are different approaches of different design approaches, and we will be covering in the other topics further. So we will go through different design approaches, and it's the TAE role to analyze that based on their test automation project, to analyze the pros and cons, and then select that, okay, that which approach is more suitable for this automation project. So this is a very important consideration while designing the selected layers of the TAA. Why we are saying selected layers? So when we covered 3.1, we went through all the layers of the test automation architecture, and we also found out that depending again on the project, it's we will choose that, we will select the layers of the test automation architecture, because it might be that the ones which we studied, all of them are not applicable for your project. So okay, so now we are saying that these approaches include but not limited to considerations for the test generation layer. So we have already covered all the layers of the TAA, and now what we are doing is that we are talking about the comparing and contrasting different design architecture approaches for different layers. So for considerations for the test generation layer, selection of manual or automated test generation. Okay, so whether we are doing manual test generation or automated test generation. Selection of, for example, requirements-based, data-based, scenario-based, or behavior-based test generation. Okay, so when in the test generation phase, it depends that which approach we are going for. Is it like requirement based, that based on the requirements you are coming up with the test cases? Is it the based on data? Either it's based on the different scenarios in the application or the behavior of the application. So these are all different approaches and they all are valid depending on what suits your project. Selection of test generation strategies, for example, model coverage. So for depending on what kind of test generation you have selected, then based on that the test generation strategies would be different as well, whatever the model you are going for. Like for example, model coverage such as classification trees for database approaches. So if you're going for a database approach, then more likely you will be doing the model coverage. Then use case or exception case coverage if you're going for the scenario based approach. And the transition state path coverage for behavior based approach, then that like it's more of like a behavior of the application, that what happens in which case, how the application behaves. Okay, choosing of the test selection strategy. In practice, full combinatorial test generation is infeasible as it may lead to test case explosion. Therefore, practical coverage criteria, weights, risk assessments, etc. should be used to guide the test generation and subsequent test selection. Okay, so we know that we have to come up with the risk approach. Otherwise, as it says that if we go on with all the full combinations, that's not a feasible approach, and then it will be like lots of test cases which might not be essential, and then we might not be able to execute all of them. So risk coverage means that some tests, they are more important than the others, and that's why those tests will have a higher risk weight, and this is like a proper way of doing that, the risk assessment, and then assigning them weightage. Okay, let's cover the next point, considerations for the test definition layer. What's there? Selection of data-driven, keyword-driven, pattern-based, or model-driven test definition. Okay, so all of these we will be covering in the further section. So over here, I will skip that because we will be covering all of these in detail. Selection of notation for test definition. For example, tables, state-based notation, stochastic notation, data flow notation, business process notation, scenario-based notation, etc. by use of spreadsheets, domain-specific test languages, the testing and test control notation, and the UML testing profile, etc. So these are all different examples depending on how you are defining the tests. So what kind of notation you are using? Either you are using any the tables for that, are you using the state based, like or the different states of the test, the data flow notation, or is it more of like the business model, business process notation based on the scenarios, or so these are different, which might be using for different approaches used in different industries. For example, TTCN3, this is basically test implementation language which supports all kinds of black box testing of distributed systems. So it's more used in telecoms or automotive industries. So personally, I haven't used it because I haven't worked in either of these industries. So that's why over here it's like more of like they have given a detailed coverage of like different industry related notations which will be used. Like for example, then UTP. UTP is a part of UML and it provides a means of using UML for test case specification. So if we are using model-based testing, then yes, maybe we'll be using UTP. Then the next point is selection of style guides and guidelines for the definition of high quality test. Okay, so when we talk about style guides or guidelines, it's nothing but we are talking about best practices. So just like for coding as well, we do have coding standards. For writing tests as well, we do have best practices. So it's just that either you're using any style guide or guidelines or coming up with your own. But it should be something which are, let's say, which is agreed between a team. So it's better if you just come up with the guideline, just use any existing guideline and use that so that if there are, let's say, 10 or 20 people in the team, then they all are following the same guidelines. And it helps as well because it is important that the tests are of a high standard. So a test which is badly written, it can result in maybe not identifying a bug. So you can miss a bug. And so there can be different practices. So for example, one of them can be that the test should be self-explanatory because let's say that if it's not self-explanatory, then maybe someone else cannot run or understand those tests. Secondly, maybe one of the guidelines can be that the test should be cross-platform friendly, so that this test should be able to run on different devices and different browsers, etc. Then we have selection of test case repositories, spreadsheets, databases, files, etc. So these are different form in which you can like kind of store the test cases. So the use of doing is that first of all, then we have reusable test, and also again if you have a bigger team, then repositories also helps with the maintenance of the test versions. Just like for coding of any project, we are using any repositories, like for example GitHub. So it helps with the version control of the code as well. So the same applies to the test repositories as well. Next is considerations for the test execution layer. Okay, selection of the test execution tools. Of course, the tool which you will be using for the test automation or execution. So that's an important consideration to make, that, okay, which tool is more appropriate and suitable for your automation project. Next one is selection of interpretation by use of a virtual machine or compilation approach for implementing test procedures. This choice typically depends on the chosen test execution tool. Okay, so first of all, let's see the difference in these two. So interpretation and compilation, these are the two main means by which programming languages are implemented. And when we talk about virtual machines, so virtual machines basically emulates real computers, and by using them you can actually emulate multiple operating systems on a single computer. So so that's what we use when we are talking about interpretation, while in the compiled language the target machine directly translates the program. Okay, next one is selection of the implementation technology for implementing test procedures. Imperative, such as C. Functional, such as Haskell or Erlang. Object-oriented, such as C++. C#, Java, scripting such as Python or Ruby, or a tool-specific technology. This choice is typically dependent on the chosen test execution tool. So again, that all these considerations are for selection of the test execution layer, that like the tool which you'll be using in the test execution layer. So in this point, it's more of like the implementation technology. Like for example, like object-oriented programming languages such as Java, C#, they were primarily designed to support imperative programming. Like for example, C is an imperative programming language, so OOPs were designed to support those. So imperative programming, which are also known as procedural, while when we talk about Haskell, then they are functional, which basically supports a functional approach to solve a problem. And these ones are also known as declarative programming. Then it's mentioned scripting language. So scripting language are basically interpreted. So these are translated into machine code when we run the code only at that time. So the examples are given Python or Ruby, and JavaScript is also one of the example of the scripted language. So again, it also says it is also like can be a tool specific technology, but it all depends that what kind of execution tool you are using. And the last one is selection of helper libraries to ease test execution. For example, test device libraries, encoding, decoding libraries, etc. So okay, so there can be different helper libraries. So the examples over here given are the test device libraries. So the test device libraries can be like for example a device lab with different mobiles and tablets, etc., which you can use for automation testing. Then for encoding and decoding libraries, so like let's say there can be an app for encoding and decoding binary files. So encoding is a way for us to translate binary files into a language which we can understand, while decoding is the process of translating encoded file to its original form, which is the binary file. Okay, so the last one over here is considerations for the test adaptation layer. Okay, so in the test adaptation layer, what we have selection of test interfaces to the system under test, selection of tools to stimulate and observe the test interfaces, selection of tools to monitor the SUT during test execution, selection of tools to trace test execution, for example, including the timing of the test execution. Okay, so adaptation layer also we have covered earlier, but like just a recap, that this is basically the interface layer. Like for example, there can be the GUI, there can be the APIs or other services, and which is the other services. So these interface layers are to our SUT, the system under test, and it has the functionality to interface with different technology implementations which are needed for testing. And in the further topics, we will be discussing more about the SUT interfaces. So we will be covering that more into detail. So for today, these are the first two things which we discussed. So the first two of the required activities, and in the next session then we will continue with the further activities as well. So I hope that you found this session useful, and I will see you then in the next one. Thank you so much. Bye.